Hi. So previously you have studied some of the region-based segmentation technique. So today in this class you will study the remaining, for example, the splitting and merging and so on. So let's begin. So here when we are speaking of splitting and merging technique. So splitting means what? If you have an image, actually I want to divide the image into various segments. So it could be one image having one foreground and one background. Maybe an image has got like this, okay? So an image, there's an image like this and you have some region like this, okay? So something, some region like this. So this is the foreground and this is the foreground, right? So this is a foreground, so this is the foreground and this is the background, okay? So splitting, if you're speaking of splitting, okay, so I can divide this whole image into two splits, that is the foreground and the background, okay? Now when I'm going to split, I'm going to see through that the regions, so I have to split based on certain criteria, right? So if it is homogeneous, I will not split if a region is homogeneous. If the region is non-homogeneous, I will split. So that is what we are going to do, okay? So what you can see here is splitting is when it's like a pyramidal structure. Go on splitting, okay? Split an image. So if at all there are three homogeneous regions, split, okay? So till you feel that within that region, so if they assume that here there's an image, it consists of four non-homogeneous regions, means I will divide into four non-homogeneous regions. If it is 2, I will divide into 2, okay? Now when I'm dividing, maybe when I divided this maybe into 4 regions, maybe one of this region has again some non-homogeneous regions, that is I can again divide it into 2 maybe, okay? So that time again I will split, okay? Merging is the other way. So I feel that the adjacent, say suppose these two adjacent regions are having the same intensity, or they are homogeneous, then I can merge and form it into one. As simple as that. That's all is splitting and that's all is merging, okay? So that is about the pyramidal structure, okay? So that is how we can represent segmentation using a quad tree, okay? So this one image I'm splitting it into four nodes, okay, wherein I can say that they have four different have four different intensity levels. That is, I can divide into four different homogeneous regions, okay? Initially as a one image it is not homogeneous, but I can divide into four sub-homogeneous regions, okay? Now this zero again might be having four different homogeneous regions, okay? So again I split, so it looks like a pyramidal structure, okay? So that could be even represented like this, okay? So you can see that there is 0, there is 1, there is 2, there is 3. Again maybe this 0, it may be again it can be divided into four different regions of different intensities, okay? And that is why it is represented like this. Maybe 1 and 2, they have different intensities. Again maybe this region 0, they may have this maybe of one intensity, so like this, again one more intensity. Maybe when I'm splitting I can feel that this two may be of common, so I can merge this, okay? So I can I have split and I can, after that even I can merge, okay? So split, go on splitting, okay? And then when I see that okay, there are some regions which have same intensity, I may have to merge those specific regions, okay, which are but I have to see through that they are adjacent in nature, okay? So that is how we have to we just say split and merge. Splitting is when you want to divide into many sub regions, because these are not homogeneous in nature. Individually they may be homogeneous, so go on splitting. And when you see that two regions close by, based on adjacency, they have a common intensity, then I can merge. Maybe this region, this region, this region, when I see the neighborhood, maybe they have common intensity, a common, some homogeneous or some criteria which makes them say that these are all same region. This intensity and maybe this end intensity may be same, but they are far from each other, so they are two different segments. But so neighborhood also plays an important role. So speaking of split and merge, so basically we define an initial segmentation into regions. So we define a homogeneity criteria and a pyramid data structure. Okay, so we are defining a pyramid data structure, that is for splitting. Okay, If any region R in the pyramid data structure, it is not homogeneous, I'll split whatever be it, I'll split into 4 child regions. That 4 may have homogeneous region, non-homogeneous region, no. Okay. If any 4 regions with the same parent, then I can merge it into single homogeneous region. I can merge them. So if no 2 regions can be split or merged, then I can go to step 3. Then I told you just now. So if any two adjacent regions R1 and Rj can be merged into homogeneous region, merge. Merge the small regions with most similar adjacent regions if it is necessary to remove small size regions. Simple it is actually. Nothing is here. So basically to understand the split and merge in the next higher level. So the algorithm is as defined follows. Okay. So what we do is we search an entire image. I'll explain this first, just listen. So search an entire image line by line except the last column and last line. So think that you can see one image here, right? So you can see one in image. When we say image, we speak of rows and columns. Okay. So we have to perform some steps for this image, okay, which is having some rows and some columns, except for the last line and last row and last column, okay. So we need to find a splitting pattern for a 2 cross 2 pixel block. So if you can see here, this is one 2 cross 2 pixel block. If you can, you have to scan line by line, one line each. So then you can find this is one more 2 cross 2, one more 2 cross 2, like that you have to go on doing. Again below 2 cross 2, 2 cross 2, 2 cross 2, and we need to perform the following steps for all the 2 cross 2 block, okay. So find a splitting pattern for a 2 cross 2 pixel block, and if mismatch between the assigned labels and splitting pattern in the overlapping block is found, we try to change the assigned labels of these blocks to remove the mismatch. We will see that, and we assign labels to the, so see this is one 2 cross 2 block. Next one more 2 cross 2 is not the, there can be an overlap, okay. So it could be like this, okay. So the next 2 cross 2 can be like this also. Here you can see here I'm trying to draw, this is one more 2 cross 2, okay. And if you see here, there is one more 2 cross 2 very close to it. You can see here there's one more 2 cross 2, okay. So how do we assign, or how do we go for region splitting and region merging, okay. So then assign labels to the unassigned pixels to match a splitting pattern of the block and remove small regions if necessary. So when we saw this 2 cross 2, there are different possibilities like this. Let us see all the 12 possible cases. You can have split like this where all the 4 regions could be same, okay, having same label. So if, or it can be like, in the second case when 3 regions have, you're dividing into 4 sub regions. So 2 cross 2, okay. This 3 could be one and this could be another, okay. Just this could be another, okay. So like that, if you see here, these in the third case, these 3 regions could be one and this could be another. Like that here, you can see 2 regions here, 2 regions here, or you can have like this 2 regions this way. You can have 2 regions this way, or you can have more regions, okay. Maybe this is one region, this is one region, this is one region, like that 3 regions here, 3 regions here, 3 regions. So one region you know how to get, 2 regions so many cases, 3 regions this many cases, and 4 regions like this, okay. And when we are going to use this 2 cross 2 block, maybe for the first time when I did a red one here, next I did a yellow one, maybe when I'm seeing the adjacency, the pixel which is here and here could, this and this could have something common. Then I need to assign a new pixel or unmerge, or maybe I have assigned this as, when I did this, okay, maybe this region is common and this is a different region. So I have assigned this as label 1 and label 2. When I do this on the next 2 cross 2 block, this and the next could also have something common. So I can assign that also as 2, and this as could be a new region which is not having the same match, okay. Like this we can do split. So split, first time we do a split, and next time when you do a new region, you do a splitting, and maybe we can merge it to the previous overlapping regions. And or based on overlapping, or based on even when there is adjacency, based on you have studied 4 adjacency, you have studied 8 adjacency, m adjacency, all this you have studied in the first module. So based on that also this single pass split and merge can be performed. Also, we should remember this equation very much, that if two regions, if some operation, that is if R1 union R2 is true, then I can say that the regions R1 and R2 can be merged. and if the mod of m1 minus m2 is less than t, where m1 and m2 are the mean gray level values in the region r1 and r2, and if it is lesser than some threshold, the intensities between two neighboring regions may not be exact the same, but if you subtract them, it could be, maybe if the you're going to represent this image in a 8-bit representation, and one could have maybe 50 as the intensity level and 51. Okay, maybe those two are in almost the same intensity levels, very close by. So if the difference of the intensity levels of those two regions is lesser than the threshold, then I can say that it is still a same region. Okay, so this is how we can go for splitting and merging technique. I have given you an overall view. Now I request you to go to the textbook and understand in very much detail. So with this, I complete my part of lecture from module 3. There is another topic called watershed segmentation, but that requires lot of visualization and some animation. So I'm going to share with you two video links. So just go through those two video links and then read the textbook. Then the contents will be very clear. And also there is a half-page content on region growing and post-processing, which I request you to just go through on your own. Or if you do not want, you can ignore that portion. So this completes module 3. So meet you next in module 4. If you have any doubts, please don't hesitate to ask. Thank you.